Hello again, and we've reached a whopping episode 7 of the entire setup of a CARF Eurosport on the Jeti. And hopefully this will be the last episode and we'll start tying up all the telemetry and alarms and things. One of the first things I wanted to do was just check our startup conditions. In that, you may remember in the earlier episode, we set up that certain switches had to be in a particular position for the system to start up as a safety feature. So let's check those. Switch on, say yes, and there we go. And it's got 4 of them flashing, 2 on this side, 2 on that side. So this one's the gyro switch, so that should be in the gyro on position. That one is the landing light switch, which ought to be off. Over here, the retracts are in the up position. Tut tut, we want those down. Good. And finally, canards to the neutral position. There we are. Lovely. That's working. Okay. Right. I've pumped up the air system, which has revealed, very interestingly, there is a very slow leak, gently hissing, out of the BVM airfill valve, which is most irksome because BVM valves are not cheap. But that also explains something, because the last time I was out flying, about a week ago, on the last flight of the day, I took off, selected wheels up, the wheels went up and promptly came back down and gave me the audio warning of gear pressure low. And I thought, oh, that's odd. I'm sure I pumped them up, because I actually use a written checklist at the airfield to make sure I've fueled up and pumped up the air systems and whatnot. I'd been sitting there for maybe 15 minutes, so I wouldn't have lost that much air, and I'm sure I pumped it up. But lo and behold, now I know why. It wasn't me failing to pump the air system up. It's got a very slow leak in it. So this video has at least found something out for me. I can go and sort that. Well, let's take a look at the pressure then. Let's switch on the model and we'll get the telemetry. Okay, we go into timer sensors, into the sensors logging setup. Here we are, logging. Do we want receiver voltage and antenna logged? Yes, by default it's there. I would never do without it. If you ever have a crash or loss of control, logging is your saviour of scratching your head afterwards and wondering what the heck went wrong. Have I got a faulty transmitter, faulty receiver, faulty batteries, what? Because it's all working on the ground now. You know, I still read of people who have a crash with their Jeti radio and they don't know why they lost control, and lo and behold, they'd switched all the logging off. So they never know. Just can't see why you would switch logging off. Anyway, what I want to do is just check that at least we've got the sensors here. So there's the MUI 30, which is wired in for the turbine. There's the central box information, and here's the M-bar. Lovely. While we're here, let's change the M-bar to PSI, because I'm British and I don't work in pascals or kilopascals. There we go. So the M-bar is working, that's fine. Let's go to displayed telemetry, add telemetry, come down here to the M-bar, pressure, double size, no. Say okay for the moment. Right, I'll just bung it up there. There we go. So the system is currently at 82.2 psi. Oh, 82.1. Yep. That's that very slow leak out of the BVM fill valve. Thank you very much, Bob. I do like those BVM fill valves, but in time, eventually, every one of them has failed. I wonder if they get the tiniest pieces of grit or dirt in them, which then just don't blow through, or, you know, you put a bit of oil in them, doesn't seem to solve it. And I think maybe that's it, just no mechanical failure of the valve. I suspect that just the tiniest bit of grit or dust gets in there, and that's it. Now, as you can see, the pressure's dropping away. And so the gear failsafe saved my model on the last flight, because if it had let me select gear up and then stayed there, by the end of the flight, there might not have been pressure to get the gear down, or certainly get it locked. And the last thing you want is the sort of landing speeds we have with these things on tarmac is any of your legs to collapse, because it certainly doesn't do the fiberglass any good scraping along the tarmac at 40 miles an hour. Pressure's dropping away, isn't it? Anywho, right, let's set up the gear failsafe then. So we need to go into menu, into timers and sensors. Is it? I have a feeling I've picked the wrong menu here. I have. Advanced properties, telemetry controls, that's what we're after. MX1. MX1 will be gear failsafe. Did I not set these up in an earlier episode? Obviously not. Enabled. Okay, come down to the sensor. It'll be from telemetry, and it will be the M-bar pressure in kPa. It's a bit irksome, this in Jeti. You select PSI in some other menus, but some of them will not let you select at all. It's just kPa, and that's it. Anyway, doesn't matter. So the type of control will be a switch, because we just want it to switch on or off if it's above or below the value we're interested in. So the condition for me is going to be that X must be above a certain value of kPa. Now the reason I'm using X as above is because we set up the logic switch that the gear could only come up when the retract switch is up and the pressure is above the threshold. So the pressure above the threshold switches on has to be X is above the pressure. Now, as I said, I work in PSI because I'm British. So what is PSI in kPa? Well, you just simply Google it. And so what I'm going to do is go for a pressure of 50 PSI. And I Googled convert 50 PSI to kPa, and it comes back with the answer 345 kPa. So let's go into there. Let's help ourselves. Point there, 100. You have to press the menu button 3 times this time to get to 100, not twice, because if I keep pressing it, you can actually see it works in 0.1. So 0.1, 1, 10, 100. So 1, 2, 3, pressed again, 40, 5. There we go, 345, plus or minus nil. So the condition is X is greater than 345, then the MX switches on. If the condition is not met, so the pressure is less than 345 kPa, the switch goes off. Duration, we're just proves to you that these are not rehearsed and really scripted. Looks like I don't know what I'm doing. Maybe I don't. Back to 345. It is annoying when it loses values when you come out like that, but there we go. I'll have to live with it. Okay, duration nil. Now, down here, default. I'm going to set the default to 100. Now, the reason for this is the default is what does it output if it can't find the telemetry? And in the early days of flying this with the gear failsafe system, I'd be flying around and at random the wheels would drop and a second or two later they'd go back up again. And I thought, what is going on? What's happening here? And I did a bit of research and found out what's happening was you'd just get a momentary drop out of telemetry or the M-bar failing to send its signal or whatever. And the transmitter says, well, I've lost telemetry, therefore the condition has failed. So the AND switch drops the undercarriage. Suddenly the sensor is getting its data back through to the transmitter. Transmitter says, oh, pressure's back above the limit, raise the wheels. Lovely. So what we want to do is stop it doing that during these momentary dropouts of telemetry. So if we set that to 100%, what it will say is, the transmitter says, I've lost data from the sensor, so default to outputting an on signal. It's not going to put the retracts up when you've selected down if it loses signal, because remember it's an AND switch, and so with the retract switch down, you just can't satisfy the AND switch even if this stays locked on. Okie doke, so that's what we're doing there. So having created that, let's say OK. if we go back to our logical switches, there's the gear failsafe, which was set up with MX1, which is on because the pressure is above the 50 psi. Is it still? Let's go and have a look at the front menu. Yep, it's still above the limits there. And where were we? Advanced properties, logic switches. God, I apologise if you can hear yet more noise in the background. I think the neighbour is fitting out a gym in his garage. So he's busy using hammer drills. Everything's against me today. Control 2, SB, is my retract switch. So if I switch the retract switch up, the switch should go on and the wheels should go up. Let's have a look at that. Does it work? There we go. Lovely. Come back here. Say OK. Right, let's check that this gear failsafe is working. What else did we have? We had a warning, I think. Have we set an alarm for it? No. So what we're going to do is add sensor, telemetry, the M-bar pressure, kPa, enabled. When it's less than or equal to, yep, that'll do. What shall we have? I'd like to get the voice alarm a little bit before it drops the wheels. And that will be at 365 kPa. Yeah. So I've chosen that. So to 365. Oh, look, it's very conveniently converting it for us. So we'll get the alarm at 52.9. I think that must be the pressure it's at the moment, which is that in PSI. And that, if we change it, does it change this PSI here? Yes. Oh, this must be an improvement they've sneaked out in one of the latest firmware updates, because I've not seen this before. Great. Okay, look. 52.9. What did I say I've set the gear failsafe at was 50 psi. So let's get a little bit of warning before then. Let's go for 55 psi. Hey Jeti, that is a nice improvement. Thank you for doing that. I can read here. Okie dokie. Right. And now if we come down to the file, will be I think it's gear pressure low. There we are, gear pressure low. So when the pressure gets down there,
gear pressure low.
okie dokie. And do I want it repeated? No, because it's just, if the repeat is on, then once the pressure goes below that value, it's just going to repeat endlessly. Repeat 3 times would be good, so it will say gear pressure low, gear pressure low, gear pressure low, or no repeats. It would just say it the once. I'll go for a 3 repeat. Okay. Now, pressure's coming down. Let's cycle the retracts to use up some of the pressure, and then hopefully we can then see, or first of all hear the warning, and then see the gear failsafe working. Right, this ought to trigger, at the very least, the audio warning, maybe the failsafe as well. Not quite, we're getting near there.
Gear pressure low, gear pressure low, gear pressure low.
There you go, that's that 3 repeat warning of our gear pressure low. I'll put the wheels down again. Now we're getting perilously close to the 50 psi at which the gear failsafe should work. So what I will do is transfer the camera to the gear, and I will select gear up, and that might just use the last of the pressure and then automatically drop it. there it goes. Our gear failsafe works. It's just selecting up used the last bit of pressure above the threshold, and that was it. Triggered it, and the gears dropped. So there we go. Lovely. Good. Nice when something works, isn't it? So that's our telemetry control with the MX1 set up. Okay, let's set up some alarms. We've already, there's a default one in there that Jeti puts in. We've set up the pressure one. What else shall we have? So let's add some radio voltage alarms, and this will be the voltage going into the central box. So we'll add telemetry, central box, input voltage 1, and we'll enable it, and the condition will be X is less than or equal to, we'll go for 5.1 volts, and the reason I'm going for that is on this model I'm using Jeti power ion batteries, which are, you know, like lithium ions, lithium polymer voltages, but ordinary servos. So I have a Powerbox Gemini voltage regulator providing the stabilized voltage power, but obviously should it start to fail, see it's outputting 5.7 volts actual at the moment. So I'll set an alarm there. Let's go for 5.2. So if that starts failing and breaking down, we'll get an alarm hopefully before it fails completely. And the voice file we want, well, we don't just want it to say battery low or something like that, because I've got 4 batteries in use here. We've got a transmitter battery, there are 2 receiver batteries, and there's a turbine battery. So getting a message that battery low is not very helpful. You want to know which one. And therefore, I'm not sure if these are Jeti built-in alarms or ones I've done at RC Thoughts, but we can specify which battery. So I don't just want low voltage. That's not very helpful, is it?
Warning, low voltage.
You think, well, which one? And that one's not very helpful either.
Warning, low receiver voltage.
Yep, again, you think, it would help to know which one. So what we're going for is low UA, BC, low U bat 2, low U bat 1. That's the one I want. I think this is one I custom made.
Warning, low voltage battery 1.
There we go. Activation switch, don't need any repeat. I don't want it repeating on and on. I'll go for the 3 times repeat. Okay to that. Then add, same thing again. Central box, the other one. Enabled, X less than equal to, what was I using? 5.2 volts, wasn't it? 2 volts. File. Low U bat 2.
Warning, low voltage battery 2.
Good. Have I just chosen the wrong one there? No, that's the correct one. I just got a bit thrown by the one in there. And again, I'll repeat 3 times. Okay. And we've got the pressure. Right. Some of the turbine ones. Add. Sensor, telemetry. Right, the MUI 30 voltage. This has been connected directly into the turbine LiPo, and therefore I want an alarm if it drops below 7 volts. You choose the voltage you want, of course. Enabled, X is less than or equal to 7 volts. It's reading 7.8 at the moment. And the file will be turbine battery low.
Warning, turbine battery low. Warning, turbine battery low.
Oh well, I set up a file that says it twice anyway, so there's no need to repeat it, or 3 times, that's fine. And so this is an example of, we now get warning that battery A is low or battery B is low going into the CB200, although probably they'd both be exactly the same, since this is just getting the output from a Powerbox Gemini. And if the turbine battery goes low, it tells us it's the turbine battery. Good. Right, add yet another one. Sensor, oops, it would help if I chose that. And this time it's the MUI30 current, enabled if X is less than or equal to, and I'm going for 0.3 amps. Now, the purpose of this is I wired the MUI's current sensing wires not into the main turbine battery supply, but into the supply to the fuel pump. And this does a couple of things for us. First of all, if the current drops below the idle current that the turbine pump takes, then the ECU must have shut the pump down. It's stopped, and therefore the engine has stopped. And you think, well, it's going to be blooming obvious if your engine stops. Well, actually, if there's other engines running in the pits behind you or other turbines in the air, it can take you several seconds to realise that your turbine has stopped, because you don't actually hear it stopped because of all the other noise distraction. You're only going to know exactly that your turbine has stopped, really, if you're the only person flying and no other engine is running. I once had it happen to me. The turbine stopped shortly after takeoff, and it was about 3 or 4 seconds until I realised I'm running out of speed and I can't pull the nose up, because there were 2 other jets in the sky and another 1 or 2 running in the pits behind me, and I could not hear the fact that my engine had stopped, whereas this would tell you your engine has stopped. So we'll set it to that. File is flame out. There we go.
Flame out, 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 flame out.
The reason it was carrying on there was, of course, because the turbine isn't running at the moment. It's done that. So we just want it to say it once or maybe 3 times.
Flame out, 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 flame out.
There we go. Okie doke. So it's done with that. So if the ECU shuts off the pump, you will now get flame out, flame out, flame out spoken at you. Okie doke.
Flame out, flame out, flame out.
There we go. And the last one I'm going to do is yet again from the MUI. This time it's capacity enabled. If X is greater than, and I'm going for 600 milliamp hours on this one. Now the purpose of this is that the milliamp hours that have gone through the pump are a fairly good correlation to the amount of fuel it has pumped. And therefore, if you take a look at the number of milliamp hours the pump has consumed on a flight and how much fuel you've used, you can set yourself a little warning. Now, I normally fly to the flight timer, but, best will in the world, occasionally you might forget to set the timer and not realise it's not counting down for you, or you've done an awful lot of wide open throttle flying. So what I've done in the past is, when I've landed, I've looked to see I've still got about quarter tank of fuel, which is what I like to shut down with, and I've looked at the milliamp count, and it's been something like 500. So I've said to myself, right, I'm going to set a warning at 600 milliamp hours that will go off and tell me I'm getting low on fuel, you got to land now. Now it's not perfect, because of course if you spend a lot of time sitting running on the taxi tank or taxiing out or waiting, especially if you're running on the taxi tank, your milliamp counter is going away for no good value at all. But at least it'll warn you early rather than late, because it's been sitting counting milliamps on the taxi tank, which doesn't count coming out from the fuel tank. So it's not a true fuel meter in that sense of what you've used since you disconnected the taxi tank, but it serves as a very good help. So we'll say that, and the file is going to be fuel low. Again, it'll be one that I've made at RC Thoughts. Here we go, fuel low warning.
Warning. Low fuel. Warning. Low fuel.
Okay. And I'll repeat just 3 times. Make sure I hear it above the noise of everybody else. And that's all the alarms that I want to set, I should say. Right, we'll go to voice output. Single voice announcements, because that's the only place that you can get the Q value. I'll set the switch. I like the spring-loaded 3-position switch. It's sprung to center, so I push it away. Pushed away. Say OK. And the sensor will be, funnily enough, it's in system, not telemetry, the Q value.
Signal 100%.
I always like to have that on every model I have, so that if any point in the flight, especially in the models at its sort of furthest point from me, I can ping that and hear what's going on. And sensors and variables, I don't really run any others on this model, but set them up as you wish. On other models where I want milliamp counts or speeds, heights, whatever, I use the 3-position switch but pulled towards me as the trigger switch, and then come into sensors and variables and set what I want as the trigger switch there. But there's no others for this one. Okay, let's go to displayed telemetry. Tell you what, we'll pop in here before we get to displayed telemetry, because I don't know if it makes any difference at all, but I like to switch off the logging of stuff that I definitely do not need. So turbine battery voltage, yep, I want that. Maybe you can change the name from UE30 to turbine if you like. Makes more sense. Okay, so turbine voltage. Yep, nice to have that in case you get a shutdown in the air. Think, what the hell caused that? If this has logged the voltage and it dropped badly, you could see that that's what it was. Current. Am I bothered about logging that? Yeah, it's the current to the pump. Yeah, we'll have that, because again, that may indicate if it was shut down, what was going on. Capacity. I'm not bothered about recording the capacity. Runtime, not bothered about that. Central box 200. Yes, I like to keep a log of the voltages, the currents, the capacities, temperature. If you had a problem, that'd be nice. And overcurrent, yeah, that's always good to have just in case. The M-bar recording of the PSI, just in case you want it. Temperature, I could not care less about keeping that. See, I have no idea whether switching those off does any use at all. It's just less for it to write to the memory card. Okay. Come down now, displayed telemetry. Okay, timer's in by default. The M-bar will let it push away. Right, add. The most important one of all, as far as I'm concerned, is the antenna. Use the double size. Yes, because we're in double path mode. That will show our antennas, and it will show the Q values. What else do I want? I will add the... Well, I would normally add the inputs to the central box voltage and maybe current and capacities as well. There is a lovely little Lua app called CB Bat Monitor, which you can get from Jeti Studio, and it puts up a lovely double-size box which covers the voltages, capacities, currents, and percentage of capacity taken out of the batteries, and it really is nice. And I say it just uses double box, whereas trying to put a lot of that in, and even then you wouldn't get the graphs and stuff, would take up 6 individual boxes. But since I'm using a regulator here, then the battery chemistry you're required to put into the Lua app is just not going to match the outputs, and if so, it's not worth doing here. So we'll take the AQ1 and voltage 2. Also no. What else will I have? Well, I've already put the pressure in, haven't I? And yep. So we'll also add then what's going on at the turbine voltage. Add turbine current, shall we? Yeah, always nice to see. And add telemetry turbine capacity, because that's the one that I can cross-check at the end of a flight how much capacity I've actually used, and does that bear any relationship in sense to the 600 milliamp hour alarm that I set. Okay, and let's just move these around to where we want. Antenna, I want to go to the top, so I'll highlight it and do that. Moving these around, by the way, actually moves the sequence in which they're displayed on the front page. The line here is the page break, so it's going to look a bit silly with the central box battery 1 on page 1 and battery 2 on page 2. So what I'm going to do is select the M bar and move that down below the line. That's to page 2. I'll keep the turbines together so the M bar pressure can go last. Say OK. Let's have a look at the front screen now. There we are. There's our timer. There's our antenna data. And there's our 2 input voltages to the central box. We'll move now to page 2. And we've got the turbine. Remember, we changed the name from MUI to turbine, so that makes sense now. Not just MUI voltage. What's that? Turbine voltage, turbine current, turbine capacity, and the M bar pressure. Ah, excellent. Okay, do you know, I think we're virtually finished setting it up. There's 2 jobs left to do. And job number 1, we go into advanced properties. We go to the wireless modes trainer, and we're going to press this button. And we're going to disable the primary module. That means disable the transmitter's primary module, which means that satellite receiver 1 will not receive any data. So it will, if the model still works, it proves to us that satellite 2 is correctly set up. So I'll press the button, disable transmission, yes. So the module 1 and satellite 1 are now disabled. Let's go back to the front screen. Prove it, see? Antenna 1 and 2 at nil, data nil. Let's look at the model, and I'll move the sticks. Does it still work? Yep. So if antenna 1 loses signal, antenna 2 is doing its job. Come back in here, switch it back on again. Now, we'll disable the secondary module to make sure that RSAT 1 is doing its job. Disable transmission, yes. Come out of here. You can see antenna 2 is all gone. Antenna 1's working, etc. Is it still working? Yep. Goody good. Now, go back in again. Switch it back on. Switch it off. What this next one, disable transmission completely, allows us to test the settings of the failsafe. And to do the failsafes, you would go into Model, Device Explorer, into the Central Box 200, into Servo Failsafe, and you would choose the mode, each of those, and then you put your radio into the position that you want, such as throttle to idle or to actual trim back to shutdown. I like to have gear down, wheel brakes on, things like that. Otherwise, controls to neutral. So you would do that. I'm not going to do it because I don't want to risk any reprogramming of the central box that's already in here running off a different memory. Okay, so we come out of there, but what we will do is just test it basically. Advanced properties, wireless modes trainer, press the button, disable transmission completely. So disabled, yes. So what I will do is pull controls like that and disable the transmission. There it goes.
Signal lost. Signal lost.
And I'll put it back
Signal
on again.
lost.
There we are. So we've checked our failsafe works. And the very last job of the lot. Model. Select model. Here's our Eurosport. I like to keep things in alphabetical order on this select model list, because when you've got a lot of models, it's a dash sight easier to find the one you're after if they're in alphabetical order, rather than just some order in which you programmed them in, which is what they're in at the moment. So we select our Eurosport and we simply press the up button until we get where we want to be. DE. So down here, D. There we go. Eurosport's in position. Say OK. And that's it. I shall now switch that off. Okay. And that's it. Thank you for watching. I hope that's been a big help to you. Sorry again, this one's dragged on really long. It's 36 minutes. But that's the end of dealing with this one.